thing, evidence of human-caused climate change. So the first thing we point to is that there are measurements, observations of temperature rising, global temperature rising. So this is from NASA and the data that they use. It's based on ground measurements for basically everything up to about the 60s or 70s. Around then we started using satellite measurements as well, so that feeds into this. But as Professor Heltman has shown you in previous classes, there's a number of different groups that collect and put together these temperature measurements. So this temperature record is pretty well established that that warming is happening and can be seen. Errors, I think standard deviation. And I think this is the 5-year mean.
Sure, yeah, those are like.
Yep, and then the annual mean, and then that's the uncertainty. Sure. So the next thing is when we look at the temperature rise, so we have that actual measurements of temperature based on our ground stations and satellites. There's a number of other ways that we measure temperature warming over the whole globe independently of those measurements that help support the idea that it's not just an anomaly. One of those is by measuring glaciers. So that's something that people have been doing actually for more than 100 years. Looking at images, looking at changes in glacier retreat. So, and then using those to understand temperature changes. So that's what this slide is showing, is some of the, looking at a lot of the different glaciers in the world and how they've been changing. You see pretty much in every case there's been a significant decrease. Another source of temperature data is boreholes. So in this case, they basically dig really, really deep holes into the earth. So this is generally into soil as opposed to ice. And because the temperature propagates down through the earth, that actually gives them a way to look at temperature in the past. And so this graph is just showing what they found there. Again, it reinforced the idea that there's been some pretty significant warming in the past century. Another source of temperature information comes from sea surface temperature. So this is like the top millimeter of the ocean surface, the water. And in that area, we also see a temperature rise of about 0.7 degrees, which is similar to the 1 degree Celsius we see for atmospheric temperatures. The little video that's playing on the side is showing sea surface temperature anomaly. So the anomaly always means it's showing you the difference from some standard number. So I think for this, in this case, it is comparing to, I think, the early 2000s and showing how it's changed from that mean. Okay, and the other reason that this warming that we're seeing in all these different areas independently is important is that it's really different than things we've seen before. So the warming is happening a lot more quickly. It's 10 times more rapid than the warming at the end of the last interglacial period. Also, the warming is global, not regional. So if we were seeing warming in just some areas, that might be just some kind of weather patterns, some kind of regional climate issue. But if that's not the case, it's happening over the whole globe. And also, we see a pattern where temperature was rising from 1910 to 1940, and then it kind of leveled off and then warmed from 1970 onwards. The best theory about why that rise is broken somewhat is because of some of the Clean Air Act and efforts to remove aerosols and black carbon, things like that from the atmosphere. Okay, so that's basically the evidence we have that the climate is warming. So essentially we take all sorts of measurements and we can see that it's warming. So the next thing I want to talk about is, so why do we think that humans are driving it? And why do we think it's driven by greenhouse gases? So the greenhouse gas effect, we've known about that since about 1859. So that's been around for quite a while. As we saw when we took the quiz, if there was no greenhouse effect, the Earth would be extremely cold, there would be no liquid water, it wouldn't be capable of supporting life. So greenhouse gas effect, you always hear about it this negative way, but it's something really positive in some ways. So, so that's something that, isn't really up for discussion. That's something we've known about for quite a while, that phenomenon exists. So we know that there are these greenhouse gases. Carbon dioxide is one of them, and that's why the Earth is habitable. But we can also measure the actual amount of carbon dioxide in the atmosphere. Since about the 70s, we do that with satellites. You can also do it with weather balloons and some other methods earlier than satellites. And what that tells us is that carbon dioxide has gone up extremely rapidly, and it's gone up higher than it has been in the last about 600,000 to 800,000 years. Part of the reason that that's a concern is that if you look at this period of the last 800,000 years or so, we've had these glacial and interglacial periods pretty regularly. And in those cases, carbon dioxide in the atmosphere and temperature were pretty closely coupled. And now we see carbon dioxide going extremely high. That makes us think, since we know that's coupled with temperature, it's going to have a large effect on temperature. And I just want to point out, there was a reading a while ago where they were talking about carbon dioxide wasn't driving temperature rises historically. And this is kind of the graph that helps to explain that. So the point is that these things are coupled together, so they move together. In the past, the climate change was driven by these Plankovich cycles. So this image that you see on the top there, which basically is very small changes in the way the Earth tilts and orbits and how the sunlight reaches the Earth. So that was the actual driver of climate change, and then carbon dioxide increased kind of as a feedback to that. So, and then that carbon dioxide increase went along with temperature increases. So just exactly what happens first, chicken and the egg kind of thing. Historically, it wasn't driven by carbon increases, but now we are driving it that way. So the other major natural cause that we think about that could have an effect on climate change, and as I just mentioned, did have a big effect on climate change in the past, is solar irradiance. And this is something we've been able to measure with satellites since about the 1970s. There are some indirect ways of looking at it for periods before that, but really our best measurements are relatively recent. And what scientists have found is there just really isn't a lot of variance in the total solar irradiance. So the sun changes a little bit. It has a cycle every 11 years. It's a solar maximum, a solar minimum. But essentially, the amount of energy that gets to Earth stays relatively constant. So the fact that carbon is changing, solar irradiance is not changing, makes us think greenhouse gases are the culprit, not natural forcing. Another thing that makes us think greenhouse gases are causing the change is there are a couple of theoretical ideas of if it were being driven by carbon dioxide, what would we see? And then we were able to take the measurements and we actually saw those things. So for example, if solar radiance was causing warming, you would expect both the stratosphere, which is the upper level of the atmosphere, and the troposphere, which is the lower level, to both be warming. Because you'd have all that energy coming through both. If it was greenhouse gases that were driving global warming, then you have this layer basically in the top of the troposphere where these gases are collecting, and they're absorbing the heat and sending it back to Earth, where it's being reabsorbed, sent back, so they're kind of keeping it in the troposphere. You would expect to see tropospheric warming and stratospheric cooling. And that is, in fact, what you do see when you take those measurements.
Back behind your head there, but the actual warming trend in the southern pole, the lower stratosphere.
Yeah.
Is there any explanation for that? Is that the pole? I mean, is that?
I don't know specifically what drives that. He's asking about the warming in the southern hemisphere, in the stratosphere. I could guess it might have something to do with ozone or with there's something called
That's kind of where the heat is.
There's also something called the southern hemisphere anomaly that has to do with solar radiation, because there's a kind of anomaly in that area also. But I can't say for sure, so we'll have to look that one up. Another similar area where scientists kind of thought about what would theoretically happen and then looked at the measurements is the way nights and days differ in their warming. So if solar radiation was causing global warming, you would expect the days to be warming more than the nights. So you would have global warming is happening all the time, but since all that energy is really coming in the daytime, the days that get hotter faster. If global warming was caused by greenhouse gases, then you would actually expect the opposite to occur. So you would have the nights warming more, because you basically have this blanket over the Earth all the time. You also, global warming causes more cloudiness. And so in the daytime, you still have the solar heat coming in, and you have the radiation from the greenhouse gases bouncing around. But because you have this increased cloudiness, the solar radiation is decreased in the daytime. So the day is warming from the greenhouse gases, but it's not getting as much solar radiation as before. In the nighttime, the only effect you have, the only change, is the greenhouse gas warming. So those are going to warm faster than the days. Okay, so all those things together basically make us think, yep, it's definitely greenhouse gases that are causing global warming. That's kind of the evidence that we base that on. So the next kind of part of human-caused climate change is, so we know we're warming. There's really good reason to think it's happening due to greenhouse gases. So why do you think humans are the cause of that? So one of the big things is that we can measure how much CO2, to a large extent, how much CO2 humans are emitting. So we know how many fossil fuels we use, the magnitude of fossil fuels, and we know how much carbon dioxide those fossil fuels emit. And so using that, we can actually get a number, and it turns out that number is very close to the carbon dioxide rises that we see in the atmosphere. Another thing that really points to humans as the driver of climate change is this ratio of carbon-13 to carbon-12. So in fossil fuels, the things that we use for energy, the carbon-13 to carbon-12 ratio is very low. In the ocean and the atmosphere, naturally, there's a higher ratio of carbon-13 to carbon-12. So now that we've been burning all these fossil fuels, what you've seen is a steady decrease in the ratio of carbon-13 to carbon-12. And they've inverted the graph here, so they're showing carbon-12 to carbon-13, which is why you see an increase. But so essentially that is like a fingerprint to say that carbon that's in the atmosphere came from these fossil fuels that we know were emitted by humans because we can measure that. Another argument given to explain how we think that it's anthropogenic changes and human-caused changes is what we see from climate models. So we'll talk a little bit more about climate models later in the lecture, why we use them, what they do, why we believe the results. But one of the things that they found that the IPCC included in their report is that when they run the models, there's a whole lot of models, many different simulations, with both the natural forcings and the anthropogenic forcings, then they're able to recreate the climate that we have today. When they run the models and they only include natural forcings, so none of the human-induced climate change, none of the human-induced forcings, then they aren't able to match the current climate. So this is just another thing to show that, it really seems like if you don't include this human-induced part, you just can't explain the question of the problem. Okay, and this slide is just to kind of sum up this argument. So this is the reason that we think climate change is happening and it's caused by humans. So temperature rise is seen in a number of different independent measurements. The temperature rise is global and it's rapid. It's different than warming that's happened in the past. We think that greenhouse gases are causing this warming because we know that greenhouse gases warm the Earth in general. We know about that effect. We know that greenhouse gas concentrations are rising in the atmosphere because we can directly measure that. We know that other forcings, like solar irradiance, are not rising. And the observations that we make of the stratosphere cooling and of the nights warming faster than the days are consistent with the theory that greenhouse gases are the cause of global warming. And finally, we think humans are causing that climate change because we can measure the amount of carbon dioxide humans are emitting, and because those carbon isotope ratios show that the changes in the atmosphere are consistent with the increase of carbon dioxide from that source.